In this video, we're going to take a look at an arc length example where we try to find the length of sine 2x on the interval from 0 to pi. So I've got a graph here of the graph of sine 2x, and I've labeled some of the points along the x-axis here. So we see it starts at 0, then it continues until it gets to pi, and then it stops. So I want to find how long is this curve. In other words, if you could take that and it was, let's say, like rope, and you stretched it out straight and you could put it beside a ruler, how long exactly is this guy? Well, hopefully we remember our arc length formula. It looks something like this. The length of a curve would be the integral from a to b, in our case 0 to pi, which I'll write down in a minute, of the square root of 1 plus the derivative squared dx, right? So you take your function's derivative, you square it, you add 1, and you put that under a radical, and this integral here that you compute will give you the numerical value, will give you the length of this curve from 0 up to pi. So let's see if we can make that happen. We'll see how we do. Okay, so here's our function again, and here's 0 to pi. So let's write down our arc length. It'll be the integral from 0 to pi for our example times the square root of 1 plus something squared dx, right? 1 plus something squared dx. But what goes here in the blank? Well, we need to actually figure that out. So we'll do that over here on the side here. So if f equals sine 2x, then f prime would be the derivative of sine 2x, and this will require the chain rule. Obviously, we all remember the chain rule. Differentiate the outside, we'll get a cosine. We leave the inside alone, so it'll stay 2x, and we'll follow that with the derivative of the inside, which will be 2, and so I'll write the 2 out front here. So all this needs to be transposed right here, 2 cosine of quantity 2x. Okay, you can simplify this a little bit. It doesn't really simplify a ton, unfortunately. We'd have the integral from 0 to pi of the square root of 1 plus, you could square the 2 and square the cosine. So matter of fact, actually I'll just wait on, hold off. Well, actually no, I'll go ahead and write the 1 because this is going to be a product, not a sum. Okay, so we'd have 1 plus 4, 2 squared is 4, then we'd have cosine squared of 2x, okay, dx, and that's really about the best you can do. So now herein lies a problem with so many of these arc length integrals here. Your integral is always going to have a radical because it's part of the formula, but it's very difficult to integrate things that have radicals, especially things with composition that it's not the square root of x, it's the square root of a function of x. Now, the idea we would have, if we wanted to do this by hand, is to use u substitution. It's a great thing to do when you have composition like this, but unfortunately, just the way the math works out for these examples, if you were to choose this inside to be u, there is nothing else in the integral to be your du. And so typically this du will have x's in it, right? Like if you took this guy's derivative, you'd have more x's. And so doing these by hand a lot of times is just not possible to do. So for this, like for an example like this, you would actually need to go to your calculator and compute this integral here. I'm going to assume that we know how to compute definite integrals on a calculator. If you're not familiar with that, then please go ahead and check out those videos that we have on doing that right now, because we've got plenty of videos that explain how to do definite integrals either graphically on a calculator or just from the main screen. We can do either of those. I went ahead and did this one before this video, and I got 5.27. So just to save some time there, I think that's what you should get after you compute this definite integral here. So in any case, what is 5.27? Well, if we go back to our original picture that we started with, that's the length of this curve on the interval from 0 to pi. One thing I would recommend in closing that you typically try to do with these types of functions is just use your common sense just to see if this answer even sounds reasonable. And so I think this is reasonable because 0 to pi being 3.14, just linearly 0 to pi would be 3.14 units. But in addition, we're not just going straight there, we're going up and down and back around. And, so having an answer slightly bigger than 3, like 5.27, sounds very reasonable. If you did this and you got an answer like 1.6, you'd say that can't be right. It's certainly at least 3, it's at least pi. And so, just make sure that your answer sounds reasonable, when you're computing these definite integrals, especially on a calculator where it's easy to make, some common mistypes and whatnot.